All right, in today's lesson, we're going to be talking about analyzing the solar system, and we're going to be using the data found in this table and the questions over here. So I'm going to walk you through how to analyze data. That means look at data and see what it means. So let's look at our first question. It says, how long does it take Mercury to revolve? I want to make sure you get that word. Remember, revolve is the same as orbit, and that means to go around a fixed object. We revolve around the sun every 365 days. Mercury also revolves around the sun, but it has a different period of revolution. So you're going to go to your chart and you're going to come to Mercury, and you can see that's your celestial object. This is the mean distance from the sun. That tells us about how far it is from the sun. We don't need that to find the revolution. Okay? Our next is period of revolution in days and years. This would be compared to Earth days and Earth years. So the period of revolution for Mercury is 80 Earth days. That means it takes 88 Earth days to complete 1 year on Mercury. So since it says revolve around the sun, we know it takes 88 Earth days to revolve around the sun. And then it says, what does the revolution tell us about Mercury's day or Mercury's year? Well, we know that the revolution is year. So it has a shorter year than Earth. If we continued, we'd find the period of rotation. Remember, rotation is our day. That's how long it takes us to spin around in place. So it takes 59 Earth days for it to make one rotation. That means it spins on its axis much slower than we do. It only takes us 24 hours to go all the way around one rotation, but it takes them 59 Earth days. This tells us the equatorial diameter. Okay, diameter is how far is across. So how big is Mercury? This is its mass. Okay, that's remember how much matter is contained. So look, 0.06. So that's not very much mass. And this tells us our density. Okay, the density, remember, is mass over volume. How much matter is packed into a single place. If its density is 5.4, we could put this planet in a big container of water and it would sink because its density is greater than 1. We're going to move on to the next question. Which is further from the sun, Jupiter or Saturn? So looking at these, you have to think, what do I need to find out the distance further from the sun, Jupiter or Saturn? So we're going to look at the mean distance from the sun. Okay, these are the mean distances. So we want to know which is further from the sun. Well, if the sun is at 0, we'll call that our starting point. We have to go down. Okay, we find Jupiter and we find Saturn. And you're going to put here, which is further from the sun. Which would it take us longer to get to? Complete your answer. If you need to pause the video to go back and look, please do that. All right. Our next question says, How long does it take for our moon? Remember, each planet can have a moon, one or more. It doesn't have to. Our planet has one moon. How long does it take our moon to rotate? That means stay in one place and spin on its axis. How long does it take our moon to rotate on its axis? So we have to find distance from the sun? No. Revolution? Remember, that's years. Period of rotation? That's days. So we want rotation. So you're going to go down to Earth's moon and look for rotation. And that's going to give you the period of rotation on its axis. So you're going to put that right there. Your next question says, which planet rotates the fastest on its axis? We know rotation, okay, the word rotate means to spin on its axis. That tells us day and night. So which planet rotates fastest on its axis? So you have to decide where you're going. What column do we need if we're analyzing the period of rotation? Well, this says period of rotation at the equator. So you're going to find out which one of these rotates the fastest. So you have to look at each time period. This means it takes 27 Earth days to make one rotation, 59 Earth days to make one rotation, 243 days for it to make one Earth rotation. Then the Earth, we know, is 23 hours, 56 minutes, and 4 seconds. So we say about 24 hours is one Earth rotation. Mars is 24 hours, 37 minutes, and 23 seconds. So it's close to 24 hours for one day. Saturn is 9 hours, 50 minutes, and 30 seconds. So it takes about 10 hours for one rotation. Saturn is 10 hours, 14 minutes for one rotation. Uranus is 17 hours, 14 minutes for one rotation. Neptune is 16 hours. And then we know the Earth moon is 27.3 days. So looking at this data, you're trying to find out which planet rotates the fastest. So which one has its shortest day? Pause the video if you need more time. All right, the next question is asking what planet rotates. Okay, we're back to that word rotates, means it spins on its axis. The slowest. So just a minute ago, we looked to try to find out what rotation was the fastest, who had the shortest day. Now we're trying to find out who has the longest day. So if it rotates the slower, it's going to take a long time to go all the way around. So you're going to go back and look at your rotation and find out which takes the longest. Make sure you look at days, hours, and minutes. Pause the video if you need to. All right. The next thing you're going to do is what is the density of Saturn? Remember, the density, how much matter is packed into the volume. So we want to go across and we're going to look at density. And you're going to go down and find Saturn and find the density of Saturn. Remember, we write density in grams per cubic centimeter. So you're going to write the density of Saturn in grams per cubic centimeter. And then it will float or sink in water, which means you have to compare it. Now remember, water, H2O, is 1 gram per cubic centimeter. That's the density of water. So remember, if it's greater than 1, it'll sink. If it's less than 1, it will float. Pause if you need to do that. All right. The next thing you're going to do is you want to look at Venus. Okay, it's going to say right here, what is unique or special about the revolution versus the rotation of Venus? So we're specifically looking at Venus now, and it wants you to compare the revolution. Remember, revolving is moving around a fixed object. That's how we get our year. We all revolve around the sun. And rotation, that's our period that we spin around and gives us day and night. So I want you to compare these. How are they sort of the same? Pause the video if you need to take some time to look at those. Think about its day and its year. How are they the same or how are they different? What is unique about them? Mostly compared to other ones. Take some time to look at other people's days and years. All right, number 8. Which planet is larger, Jupiter or Mars? So to find that out, you're going to have to look at equatorial diameter. That's going to tell us how big it is. So looking at the equatorial diameter, these are all in kilometers. You're going to determine which is bigger, Mars or Jupiter. Pause the video if you need to take some extra time. All right, number 9. Which planet has the most similar length of day or period of rotation to Earth? So talking about the period of rotation, remember that's the period it takes for it to spin around on its axis one time. That gives us day and night. So which other planet has a day-night cycle that is almost the same as Earth's? To do that, again, you're going to have to look at period of rotation. That's our day-night cycle. All right, number 10. Do any planets have a similar length of year to Earth? So we have to decide if we're talking about year. We're talking about rotation or revolution. Well, we know rotation gives us our day and night. Revolution means to go around a fixed object or to orbit. So that means revolution gives us our year. So, we want to look at the period of revolution to see if there's anyone that has a period of revolution that's close to the length of our year. And if it isn't exactly the same, well, which does have the closest? So you're going to take some time and look at the length of revolution, making sure to look at day and year notations. Remember, our moon is not a planet. So we're not looking at the moon when we're trying to find out if a planet has a similar year. Okay. What planet revolves the fastest? There's the word revolves. which means it's orbiting. It's moving around the sun. Which planet revolves the fastest around the sun? Does this revolution indicate a short day or a short year? So you're looking at the period of revolution. Again, remember, we're looking for planets, so we're not looking at the Earth's moon. Earth's moon is a celestial object, but it's not a planet. We want to know what planet revolves around the sun the fastest, not which moon revolves around the Earth the fastest, because it would be our one moon. There we only have one. So once you have found it, you're going to put your answer right here and then indicate, is that period of revolution talking about a day or a year? All right, number 12. What revolves the slowest around the sun? Another way to say this would be what planet orbits the slowest or takes the longest to go all the way around the sun. Okay, remember, orbiting is moving around a fixed object. So going all the way around the sun. So we're going to go back to period of revolution. We're going to find out which one is moving the slowest around the sun. And finally, your bonus. Do you see a relationship between the distance from the sun, here's our mean distance from the sun, okay, and the length of the planet's year? So is there a relationship between how far it is from the sun and how long the year is? So think about that, pause the video, and then you can complete your answer right here. Do you see the relationship? Now that you've completed your analyzing the solar system data, you may go show the teacher and look at the key so you can check your answers.